We're going to do solving a quadratic with an inequality. So we're going to start with 3x squared greater than or equal to 5x minus 2. So what we're going to do is, because it's an inequality and it's a quadratic, we don't do like it's an inequality in linear. So what we're going to do is go back to something we already know. So one of the things that we do know is an equation. I know how to solve an equation. So what you do here is you change the inequality sign to an equal sign, and then we are going to set it equal to 0. So we get the 3x squared minus 5x plus 2, and then it's going to equal to 0. Now in this case here, we know that it's going to be y equals, and that y is equal to 0, and that's how we find the x-intercepts, because x-intercepts are always going to be a number, and the y will always be 0. So that's what we want to do on here. And so when we do that, we are going to factor this, and we're going to use our two little parentheses, and we're going to do it the guess and check method. So when we guess it, it's going to be the factors of 3, which is 1 and 3, and the factors of 2, which is 1 and 2. And so then I could put the factors here, and then 3x here. So it's going to be a 1 and a 3x, and when I multiply them together, it's going to give me a 3x squared, and then this is a 1 and this is a 2, and when I put these two together, it's going to give me the 2, which is what I'm looking for. So that's the outside terms and the middle terms. So we filled that. We got that requirement done, but now we have to also get the requirement of the middle term. So the middle term is based off multiplying the two outside terms and then the two middle terms. So when I do that, if I multiply that, I get the 2x here, and I get a 3x here. Now the problem here is that I want to add them or subtract them in order to get 5. If I add them, I get a positive 5. If I subtract them, I get 1 or a negative 1. So what I want to do is I want to add them, but I have to keep the sign there. So the sign would mean that this would have to be a negative 2 and that would have to be a negative 3, because when I add those, that has to give me a negative 5. So that means that this is going to be negative and that is going to be negative. Now I could have done it the other way around, checked it, and then I could have switched. When I put those in there, the 2 could have been over here and the 1 could have been on the other side, and then I would have had to so this 1 and that 2 could have switched, and then through the guess and check, you'd know that you have to switch them the way they are now. Alright, so now I have factored them. So I have x minus 1 is equal to 0. Let me get that in the other color. X minus 1 is equal to 0. 3x minus 2 is equal to 0. X is going to equal 1. And then here we could do the math and you get 2 over 3. So now these are the x-intercepts because I replaced the y with 0. And then I solved for it, and I got what x equals. So these are the numbers that go here, and the y is 0, so these are the x-intercepts. Now, if I were to graph this on my, this is the x-axis, so this would be, so that's positive. Okay, so that would be the x-axis, and so this is going to be 2/3, because that's less than 1. So it'd be 2/3, and then 1 there. And so I know that since this is the x-intercepts, that the graph has to go through these 2 points. I know that the leading coefficient is positive. I know it's a quadratic, so therefore it's going to be concave up. And it's also going to be a parabola. So the leading coefficient being positive is the concavity, that it's concave up, and the square means that it's going to be a parabola. So now I need to decide which ones I want. So this is where I go back to the inequality. So this is where I have this. So I am going to change, I'm going to go back to the inequality, 5x minus 2, and I'm going to say 3x squared, and I'm going to solve it for 0 because I always want to know whether I'm looking for positive values or negative values, and that's what tells me that. So 5x minus plus 2 is going to be greater than 0. So we have 3x squared minus 5x plus 2 is greater than 0. Now if I take any x value and I substitute it in here, what I am going to get back is going to be a y value. So if I take, let's say, an x value of 0, substitute this back in here. So 0 minus 0 plus 2, that 2 is going to be the ordered pair 0, comma 2. So it's the y value that it's giving you back. Okay, so in this case here, these are all y values. When I replace the x with any x value, when I get it back, it's going to be my y value. So the y value here, I want them to be greater than 0. Greater than 0 means that any number greater than 0 is positive. So in this case here, I'm looking for positive y values. So that's what the inequality is asking me to find, positive y values. Well, if this is the x-axis and this is the x-intercepts, then everything above here are the y values that are going to be positive. So these are positive y values and these are positive y values. If this is the x-axis, anything below it is going to give me negative y values, but I want positive y values, so they're positive from negative infinity to 2/3. Because it's equal to, that means I want y equal to 0. Y equal to 0 are the x-intercepts. So am I including the x-intercepts? The answer is yes. So then I do a bracket when it's including, and then I do union, and then it's going to be a bracket 1 to infinity. And so the answer and the solutions is that any number that is less than 2/3 is going to make this equation true. Any number greater than 1 is going to make this equation true. So if I choose anything from there and I substitute it back in, I am going to get a value that is going to make the equation true. So your solution is this. Okay?